We are going to find the area of the circle via integral. I'm going to do with using three different methods of defining area of circle using integral, definite integral. Okay, let me see. All right. So we are going to, let's find first the area for the one sector or the area under this arc. And once we find the area, then we can multiply by 4 to get the area of entire circle, right? So we have first method. The area of circle is going to be equal first 4 times area 1, and this is going to be our area 1. Okay, so this is going to be equal, area of circle is going to be 4 times. Now the formula of this sector, for the area of this sector, it's going to be equal 1/2 integral from alpha to beta and r squared of phi d phi. Now r squared phi, those are polar coordinates, r of phi, because phi is an angle, and that's why we put alpha to beta, and 1/2 integral alpha to beta of r squared phi, that's area of this sector, area under this arc. Okay, so where 2 is going to be gone, here we will have 2, and since our phi, this is this angle, this is radius r, our phi is changing from 0 to 1/2 pi, first quadrant, right? Okay, and r of phi, it's going to be our radius, uppercase R. Therefore, we can rewrite this 2. So alpha, it's going to be represented as a 0. And beta is going to be represented by 1/2 of pi, right? And we are going to have, instead of lowercase r squared of phi, we will have uppercase r squared d phi. Let me make it smaller, this pi over 2. Okay, bring it down a little bit. All right, this is this, and we are getting 2r squared integral 0 pi over 2 and d theta. So from here we have 2r squared, so theta, right? Theta pi over 2, rather saying this is phi, not theta. This is theta, so phi. This is going to be equal 2r squared times pi over 2, and second one is going to be 0, right? Once I plug phi as a 0, the whole thing is going to be gone, and we will have 2 and 2 is gone, and we have pi r squared. Okay, now second method, that's what if you don't know the formula of this area under this arc of in first quadrant? What if you don't know the area, how to calculate the area of first quadrant? Then we are going to go following way. So the area of entire circle is equal 4 times A1. And this is going to be equal 4 times. So it's going to go from 0 to R through to radius. Okay. And what function it's going to be limited this? Let's find out this function. Okay. And this is changing our y, right? Look here. This is, and until it's becoming half a pi. So formula for our circle is x squared plus y squared equal r squared, and y from here is equal plus minus square root r squared minus x squared. And because we are using our first quadrant, so in our case we are going to use only plus sign, right? And this is going to be square root r squared minus x squared dx. Okay, let me clean this. And we are going to solve this with substitution, where whoever knows polar coordinates will understand. Whoever not, you have to wait until go over polar coordinates. So substituting with x is equal r sine t. That's why we covering r sine t. It's a polar coordinate. And dx accordingly, it's going to be r cosine t and dt. Okay, since we are going through substitution, that means we have to replace this limit of integral 0 and r, right? So low limit is 0. So if I plug here x is 0, we get r is equal sine t. So when we get at what value of t we get 0, when sine t is 0 degree, right? Right here. So which means t1, this is we're going to replace with t1, which is going to be equal 0, right? And the other one, r, I'm going to substitute also this x. It's going to be r is equal r cosine, r sine t, I'm sorry, r sine t, which means divide by r, we are getting 1 is equal sine t. And at what value of t we get sine t equal 1? That's here, half a pi. So at the upper boundary, it's going to be t2 is equal half a pi, right? Okay, so let's replace the boundaries, and let's see what we are going to have. So is equal 4 times integral from 0 to half a pi, right? Pi over 2. Okay, and now what I'm going to do, I'm going to change this square root r squared minus x squared. Let me rewrite right here. R squared, instead of x, I'm going to plug r squared sine squared t, right? Substitution. And dx, it's going to be r cosine t dt. This is going to be equal 4 from 0 to half a pi. So the r squared, it's a common factor, comes out r, and because it has nothing to do with t, by which we are doing integration, so r will come out. And we have underneath 1 minus sine squared t, and then r cosine t. So this r also I can take out actually, and here it's going to be r squared, right? And I will have here cosine t dt. So this is going to be equal 4r squared integral from 0 pi over 2, and this is going to be equal 1 minus sine squared is cosine squared, so it's going to be cosine t and cosine t times cosine t. Oh, here also I don't know why I put cosine t dt. Yes? Okay, so this is equal 4 times r squared integral 0 half a pi cosine squared t dt. And applying formula, cosine squared t is equal 1 plus cosine 2t over 2. This is equal, I am applying 4 r squared. This 1/2 here, see in the formula, 1/2 I'm taking out also. 0 half a pi, which is going to be, this 2 is gone, this is becoming 2. Okay, and we have here 1 plus cosine 2t dt. Okay, so if I break down, I'm going to get 2r squared integral 0 pi over 2 dt plus, since I have here cosine 2t, this 2 I'm going to, this 2r squared, this 2 I'm going to squeeze under dt. It's going to be only r squared from 0 to pi, half a pi, and it's going to be cosine 2t and bringing under derivative, right? d 2t. And from here we are getting 2r squared t from 0 to half a pi plus r squared sine 2t from 0 half a pi, and we are getting 2r squared times half a pi, these 2 and 2 gone, and minus 0 obviously here, and then plus r squared sine 2t. Instead of sine 2t, I'm doing multiply times twice pi over 2, and I'm getting sine pi, right? And the sine pi is equal 0, correct? Let me rewrite. R squared pi plus r squared sine pi. Sine pi is 0, therefore this entire term is becoming 0, and the answer we are getting pi r squared. So this is the second method how to get it. The area of circle. It's a little bit longer, but it's still working. This is just in case if you don't remember the formula for the area of the first quadrant, how much it will gonna be using polar coordinates. And I will go over third method also. All right. Third method of calculating the area of circle via integral. So we know the formula for circle is x squared plus y squared is equal r squared. Parametric form is x is equal r cosine t. Let me write down as a function x of t, and y of t is equal r sine t. And this is what we have, parametric form of circle. So x of t is equal r cosine t, and y of t is equal r sine t. Okay, from here we know that area of circle is equal four times the area of the first quadrant, right? I wrote down at the beginning, and this is equal, since we have 4 times, so it's running from 0 to r, and we are writing down y over at the function y of t dx. So this is going to be equal, yes, dx, y of t and dx. So to put dx under derivative, it's going to be 4 times 0 to r y of t, and derivative of x is going to be x prime of t and dx, right? And dt. Okay. So what we are going to have from here, this is going to be equal 4 times. We are going to plug when x is equal this 0. We are going to get 0 is equal r cosine t, and in what case cosine t is equal 0? Here, right? Cosine equals 0. So t is going to be equal half a pi. So here we have replacing half a pi. And when we have r, we are going to substitute. R is equal r cosine t, which is 1 is equal 1 cosine t, and t is going to be equal 0, right? Because at the point of 0, cosine t is equal 1. Okay, so we are going to have from half a pi to 0, and this is going to be r sine t, that's r at the y of t, and times x prime derivative, it's going to be negative r sine t, right? Because derivative of cosine is negative sine t, and here we have dt. This is going to be equal negative 4, this negative r is coming out, r squared, okay, and When I'm going to replace sine squared, I will have here sine squared, and sine squared is going to be equal 1/2 pi over 2 and 0. Sine squared t is equal 1 minus cosine 2t over 2, right? And we had here cosine, yeah, cosine also we have. So this is equal 1 minus cosine 2t and dt. This is 1, this is 2, and here we have it's equal negative 2 r squared. So 1 dt, it's going to be just a t from pi and half till 0, and then plus cosine, since we have 2, this 2 is going to squeeze under d2t. So this way we are getting r squared sine 2t. And why it become plus? Because we have the negative cosine 2, and with this negative it's going to become positive, right? And here we are getting 1/2 pi over 0. So what we going to get from here? It's very easy. We're going to get from here, for first term, it's going to be negative 2r squared, so times 0, which is going to be gone, and minus negative 2r squared times pi over 2. 2 and 2 is gone, and then plus r squared sine 2 times 2 and minus r squared sine 2 times pi over 2. So what do we have here? This one is 0 right away. Here we have positive r squared pi. So sine 0, here it is, 0 degree, it's gonna be equal 0, which is this one also becoming 0, right? And sine 1/2 pi, it's sine pi, I'm sorry, because with 2 is gone for this last one, right? Sine of pi, it's going to be also 0, so this is also getting 0. And we are having r squared pi, meaning pi r squared. So I covered 3 methods of calculating area of circle via integral. If you like math and you like the way I explain, then please subscribe and let me know that you are enjoying. Put the like there so I will know. Okay, thank you for watching.